Hi guys. So today we are going to do some of the same stuff that we did last class with degrees, except we are now going to look at those measurements in radians instead. So we did an activity in class where we learned that a full circle, which is 360 degrees, is 2 pi radians. So we're going to use that to help us find coterminal angles to start. So the way I found a coterminal angle in degrees was I added or subtracted 360. Well, the way I'm going to find it in radians is I'm going to add or subtract 2 pi. So if I want to find a positive coterminal angle here, I can add 2 pi. The only problem is, in order to add fractions, I have to have a common denominator. Currently, this is 2 pi over 1. So my common denominator is going to be 3. So I'm going to multiply the top and the bottom by 3. Whenever you add fractions, you add the top, you keep the same denominator. And if you were to add pi and 6 pi, well, if you had 1 pi and you added 6 pi's, you would have 7 pi's. You add them just like you would add x's, right? X plus 6x is 7x. All right, that's how it works when we're adding it in terms of pi. So now let's do the same thing, but find a negative coterminal angle. So I'm going to subtract 2 pi. Well, again, it's 2 pi over 1. I need a common denominator, so I'm going to multiply the top and bottom by 3. And then I'll subtract. Pi minus 6 pi is a negative 5 pi at the top, and 3 is in the denominator. So in these next ones, we're going to continue to find coterminal angles, but we specifically want a coterminal angle that's between 0 and 2 pi. So what that notation means is that the angle is bigger than 0, and the angle is smaller than 2 pi. So let's start with negative 8 pi over 7. So negative 8 pi over 7 is obviously smaller than 0 because it's negative. So in order to make it positive, I'm going to need to add 2 pi. So in order to add 2 pi, I need a common denominator. So I'm going to multiply the top and the bottom by 7. Now I can add across the top, and I get my final answer. All right, let's look at the next one. So the first thing I need to do is I need to figure out, is 12 pi over 5 in between 0 and 2 pi? Well, let me rewrite 2 pi, that's 2 pi over 1. I want to write that with the same denominator. 2 pi over 1, if I want that to be something over 5, I would have to multiply the top and the bottom by 5. So 2 pi is equivalent to 10 pi over 5. 12 pi over 5 is more than that. So in order to get an answer that's in between 0 and 10 pi over 5, I need to subtract 2 pi. I'm going to do that with a common denominator, which is 10 pi over 5. And when I subtract, I get 2 pi over 5. All right, let's look at this last one. Negative 15 pi over 4 is obviously less than 0. It's negative. So I need to add 2 pi. I need to get a common denominator. So I'm going to multiply the top and the bottom by 4. And then I can add across the top. And then I can do the same thing again, because remember, there's more than one coterminal angle. This angle still is not between 0 and 2 pi. So I'm going to go ahead and add 8 pi over 4 again. And I get pi over 4, which is in between 0 and 2 pi. All right, what we also can do is we can convert back and forth between degrees and radians. So we'll just fill in this information. We already said there are 2 pi radians in a circle. So to find a coterminal angle, we add or subtract 2 pi. We can convert from degrees to radians, all right, because we know how much 1 degree or how much 1 radian is. If I want to go from radians to degrees, I'm going to multiply by 180 over pi. If I want to go from degrees to radians, then I'm going to multiply by pi over 180. And one of the ways that you can remember this, typically with radians, you want to end up with a pi in the top. And if you're going from radians to degrees, you're typically going to start with a pi, and you want the pi's to cancel, which is why you want a pi in the bottom. All right, so let's go from 60 degrees. That would be 60 over 1. I would multiply by, I'm going from degrees to radians, so pi over 180. So that's 60 pi over 180, and then I just need to simplify my fraction. They're both divisible by 10. Those numbers are both divisible by 6. So 60 degrees is pi over 3 radians. All right, let's go with 240. That's 240 over 1. We're going to multiply by pi over 180. And then we're going to simplify our fraction. So I can get rid of those zeros. Those are both divisible by 6. And I end up with 4 pi over 3. And then the last one, again, it's 135 over 1, multiply by pi over 180. Those numbers are both divisible by 5, so I can divide them both by 5, and that is going to give me, I think, 27 pi over 36. Those numbers are both divisible by 9, and I end up with 3 pi over 4. All right, going the opposite way. Again, we want the pi's to cancel out, so I'm going to multiply by 180 over pi. Now, if you want, you can actually simplify before you multiply. We could have done these on the other ones, but anything diagonally, top and bottom, that's divisible by the same thing, you can simplify. So, for example, 6 and 180 are both divisible by 6. So I can do 6 divided by 6. I can do 180 divided by 6. And now I can go ahead and multiply. And that's going to just be a little bit simpler, and it's going to give us a little bit of smaller numbers to work with. Again, those pi's cancel out, so I end up with 30 degrees. So on the next one, again, that's a good time when we're going to multiply by 180 over pi. If you want, again, you could just multiply straight across the top and straight across the bottom and simplify. Or you can save yourself a little bit of work, and let's go ahead and simplify. Those are both divisible by 3. Then when I multiply across, I just get 300. It saves me just a little bit of math and makes it a little bit easier. So this last one's a little bit tricky. Most of the radian values that we're going to use in this class are going to be in terms of pi. However, they don't have to be in terms of pi. You can have 1 radian or 3 radians. We typically talk about them in terms of pi because those are the nicer angles that we'll work with more, but it is possible to have a single radian. So for example here, this is 10 radians. We're still going to multiply by 180 over pi. Our answer is just going to look kind of ugly. This is going to be 1800 over pi degrees. Now that actually stands for a number. That's 1800 divided by 3.14, which is 500 and something degrees. I can't remember the exact number, and I don't have my calculator on me. Let me pull it up real quick. All right, so if you actually did 1800 divided by 3.14, you would get about 573 degrees. So that's what it actually stands for. So most commonly, you're going to see ones that look like these first two. But it is possible to have a radian value that doesn't have a pi in it. All right, so the last thing that we're going to do is we are going to graph these radian values, and we're going to find the reference angle. These are probably the 2 hardest things. Now, this little chart I'm going to show you, these are kind of the steps I typically walk through. You don't have to do it this way, but it helps me, and this is the way I'll usually do it. So the first thing that I do is I write 1 pi and 2 pi with the same denominator as the given radian value. So I'm going to start with pi over 6. In order to graph this, I want to know what 1 pi and 2 pi are with the same denominator. So 1 pi, if I have a denominator of 6, has to have a top of 6, because 6 over 6 is the same thing as 1. 2 pi is going to be the same thing as 12 pi over 6, because again, what I'm doing here is I'm taking 2 pi and I'm multiplying by that common denominator. So that's the first thing I'm going to do. The reason that I'm doing that is because it's going to make it easier to see which quadrant this goes in. So the next thing we need to do is this angle between 0 and 2 pi. If it's not, we need to find a coterminal angle. So pi over 6, is that in between 0 and 12 pi over 6? And it is. So we don't need a coterminal angle. Okay, it is in between those 2 numbers. So now we're going to figure out where this angle is going to fall. So what I'm going to do is I'm going to label 0. That line over there is 180, which is pi, but I'm going to write it with the same denominator. And then I'll also write 2 pi, which I'll write with the same denominator. So now we need to figure out where 1 pi over 6 is going to fall. So if I start at 0 and I work around this circle, if I go to 1 pi over 6, I'm not going to go past 6 pi over 6. Then I need to figure out, am I closer to 0 or closer to 6 pi over 6? Well, 1 pi over 6 is closer to 0. So that is my angle. Now we're going to find the reference angle. Remember, the reference angle is how far away is that angle from the x-axis. Well, if this is 0 and this is pi over 6, our reference angle is pi over 6. All right, let's try another one. Again, let's write 1 pi with the same denominator. So something over 8, this has to be 8 pi over 8. So whenever we write 1 pi, those numbers are always going to be the same. The number at the bottom is whatever the original denominator was. 2 pi has the same denominator. Since it's 2 pi, the top number is going to be double that number. All right, so now let's see, do we need a coterminal angle? Okay, is 11 pi over 8 in between 0 and 16 pi over 8? Yes, it is. So we do not need to find a coterminal angle. Now let's label those points. Here's 0. Here's 8 pi over 8. Here's 16 pi over 8. All right, now let's figure out where 11 pi over 8 is going to fall. So if I go around this circle, 11 pi over 8 is going to be past 8 pi over 8. Now I need to figure out, is it closer to 8 pi over 8 or closer to 16? Well, 11 is 3 away from 8, and it's 5 away from 16. So we're closer to 8, so we're in quadrant 3. So there's my angle. Now let's find our reference angle. So again, the distance between the x-axis, this is 8 pi over 8. This is 11 pi over 8. So the distance between there is 3 pi over 8. That's my reference angle. All right, we're going to do 2 more, or 3 more. Let's try this next one again. Write 1 pi and 2 pi. 1 pi has the same numbers. 2 pi is double. So I need to figure out first, is this between 0 and 2 pi? It is not, okay? 8 pi over 3 is more than 2 pi. So I need to find a coterminal angle. To do that, I subtract 2 pi. 2 pi with a common denominator is 6 pi over 3. So if I subtract those, now I find a coterminal angle. Now we're going to sketch it. So we're going to figure out, here's 0, here's 3 pi over 3, here's 6 pi over 3. 2 pi over 3, we're not going to go past 3 pi over 3. So is 2 pi over 3 closer to 3 or closer to 0? 2 over 3 is closer to 3. So I'm going to be in quadrant 2. Now if I actually sketch this though, I need to consider that I did find a coterminal angle. So I draw the whole circle and then I end there. All right, the last one we're going to find is our reference angle. So again, we're going to find the distance between that terminal side and the x-axis. So if this is 3 pi over 3 and this is 2 pi over 3, the distance in between is 1 pi over 3. All right, for negative angles, it's up to you if you want to find a coterminal angle. All right, let's go ahead and list our 1 pi and 2 pi. This is 4 pi over 4. This is 8 pi over 4. So if you want to find a positive coterminal angle, you can. And if that's easier for you, then do it that way. What I'm going to do, though, is I'm just going to look at this from the negative direction. So this is 0. And if I move in the negative direction, this is negative pi, which, again, I'm going to write it with the same denominator. That's negative 4 pi over 4. And this is negative 8 pi over 4. So I'm just going to look at this moving in the negative direction. So if I start at 0 and I go to negative pi over 4, so I'm going to go in this direction. I'm not going to go past 4 pi over 4. I need to figure out, am I closer to 0 or closer to 4? I'm closer to 0. So that is negative pi over 4. Then again, the reference angle is the distance in between there. And that distance is pi over 4. Remember, we always write reference angles as a positive number. Now, if you wanted to find a coterminal angle, you could. Again, this was kind of optional. Let's say I did negative pi over 4, and I add 2 pi. Well, I'm going to add 8 pi over 4, which gives me 7 pi over 4. So if I looked at this from the positive direction, 7 pi over 4 would still be in quadrant 4. Okay, if I start this way and went around 7 pi over 4, I would still end in the same place. All right, let's do our last one. So this is 3 pi over 3 and 6 pi over 3. Again, remember, those numbers are the same for pi. That's double for 2 pi. We want all of the denominators here to be the same. All right, we'll go ahead and label them. Here's 3 pi over 3, and we're going to go in the negative direction this time. Here's 0 and negative 6 pi over 3. So if I'm going negative 5 pi over 3, I'm going to move this way. I'm going to go past, it's more than negative 3 pi over 3. So now we need to figure out, is negative 5 over 3 closer to 3 or closer to 6? Well, it's going to be closer to 6, so I'm going to end up in this quadrant, and I went in the negative direction. All right, so the last thing is just your reference angle. Let's find that distance. If we went negative 5 pi over 3 to 6 pi over 3, the distance in between those is just pi over 3. All right, so that is it for your radian measures.